nice interactive mode that you can use to pick different commands. So I can choose the build command this way, and then I can choose the target that I want, for example, Nginx latest. And that's pretty much it. If I run it, it starts, it goes through a set of steps. One of the steps is and it ships it back, and then based on that information, it builds a new image. And if we look at the image, Docker images, Nginx. Wow. So we went from 133 megs to 11 megs. And
thanks everyone for joining us today on the CloudNative.fm podcast, episode number 31. And today we are talking about DockerSlim with my guest, Kyle Quest. I think you've been in the past figuring out how to build the slim images using the Docker, because we all hate, or we all avoid to build the giant Docker images. So finally, we have guest on this show who will talk about his experience of building these two tools, DockerSlim and DockerSlim.AI. And he's been a wonderful figure in the cloud native ecosystem. So over to you, Kyle. Introduce yourself to my audience and tell about your experience of being into the cloud native ecosystem.
Yeah, I'm happy to talk about Slim and DockerSlim and how it all started. Yes, it is a common theme when you're building containerized applications. A lot of times you end up with huge containers, even for basic applications. And it's been like this from the very beginning when Docker was created. And if you try to go through the standard route to address that, it's actually complicated. And it's a side effect of the general problem with cloud native and cloud infrastructure in general. There's a lot of opportunities and interesting possibilities, but it's a lot of complexity and manual work too. For application developers, it's a challenge. Imagine you're a web developer, and now you need to be an infrastructure expert. Now you need to know the internals of Docker, how to author Docker files, and with lots of internals exposed to you that you need to be aware of to get the outcomes you need. And that's just the hard way of doing it. And like, to me, a lot of times it feels like writing a web application in assembly, which is not something people do probably at all right now, but this is how it used to be. People used to write applications in assembly language, but we evolve. But if we look at where we are with the cloud native infrastructure, we're still kind of in the assembly phase of the cloud native infrastructure. We're doing things the hard way. You need to know a lot. You need to do a lot of things manual. And it doesn't have to stay this way. It's just that's where we started. And that was the original idea, that it shouldn't be that difficult. And to get to the desired outcome, I thought, well, if we look at what happens, it's really about the applications and what they need and how they work. So I figured, well, I've done a lot in the past with security. I've been involved in security for a long time. I don't want to say how long. But there are a lot of interesting techniques and tools out there that are used to detect malware and all of that. And I figured, what if I just turn it upside down, and instead of pointing all that tech at bad software, I do that with the good software. So what will happen? And DockerSlim happened. But technically, the original version didn't even involve Docker, but the concept of an application-centric approach is kind of similar. You focus on the application as opposed to the infrastructure, and then you can harness that information about the application, and you can automate a lot of things that you have to do manually when you know what needs to be done. Otherwise, it kind of happens when you think about the application and you figure out, well, this application needs this and that, and you have to do it because there's no other way. But if you capture the information about the application, there is another way. And it started as an opportunity to introduce DockerSlim. It started as a hackathon. That was a global hackathon Docker hosted, and it was one of the projects. It was an interesting way to do it. It was just a day to get something working, and it was barely working then. But eventually it matured, and it gained a lot more traction, and because a lot of other people had the same problem. Because like I said, application developers are not infrastructure experts, and it's just too complicated. And even if you know what you're doing is just the extra work, the time it takes to do it, it isn't something that you want to do, because it's the time you take away from other things, more important things that you would spend on your application. So regardless whether or not you're an expert, you really don't want to waste your time. And that's the idea, and that's what DockerSlim does. Obviously, it has room to grow and evolve in terms of how it does it. But what it tries to do, it tries to make sense of the application in the container, doing static analysis and dynamic analysis, and then based on the information it collects, it reassembles the application image based on the application needs, and that's how it's able to get to the desired outcome, and that and in some cases significant change in size. In some cases it's like for script-based languages, it's pretty common to get 10 to 30 times improvement. For some of the compiled languages, especially if you have the build tools, it's even more, because the build tools take up a lot of space and all of that. And it's still, people get really excited about seeing what it looks like whenever they see it for the first time.
Yes.
But it's actually a lot more than just minification, and there are a lot of other capabilities like X-ray that helps you understand what's in your container image, and linting and all of that. So there's a lot more to play with, and the idea there is to kind of improve the overall developer experience, empower the developer to get things done faster. And SlimAI takes that to the next level, where it provides this end-to-end integrated flow where you can connect to a whole bunch of different registries and your internal systems, and you can automate a lot of things.
Yes, absolutely. That's a great news for all of us. Because and tell us about this notion of being the slimmer images, because we all tend to think about the as you draw a wonderful conversation to get started with, because that same Docker file that is having the code in it, plus the dependencies, plus the infrastructure's code in it. So before that, we don't live in that world where we manage to understand that my application works on this node, this machine, Windows machine or Linux machine. This is not the job of the application developer. It's a job of operation manager or these other platform engineers. They write the code, they write the script to host their application into the particular Linux or Windows machine. But that same logic is written in that same Docker file. So it's really difficult for the developer to understand how many steps in there and how my application is written in there. So it's remove a lot of the complexity of my application code is not working on your machine and your code is not working on my machine, but it's end up having so many integration in it. So tell my audience about this view of slimmer images, why it's so important as respect to the security concern, and why we need to care about the slim images in the Docker file.
Sure. And it's kind of funny that you mentioned the DevOps role and what they do, and it all goes back to one of the concepts behind DevOps, or one of the favorite definitions I have. DevOps is about you build it, you run it. It sounds great on paper, but again, now you have application developers having to be infrastructure experts. Not realistic, not possible. This is why we got the DevOps engineers, because there's a disconnect between this definition and reality. You can't expect developers to be experts in infrastructure. So we naturally introduced this new role responsible for the infrastructure. But when you do that, you have another disconnect. Now you have one person who knows the application and another person who knows the infrastructure, and it gets a little even more complicated, because the infrastructure person doesn't know the application and what it needs, and it takes a lot more cycles to get to something that's delivered to production, and that's one of the things that you can get by capturing the application information. You can accelerate the cycle, and you can have a common base. And so why is it important? There's a number of reasons. If you look at the container best practices, they talk about having smaller images, having smaller attack surface when it comes to security, and it's interesting that the concept of reducing the attack surface is becoming mainstream, because, like I said, I come from security. I've been doing that for a long time, and now it's a mainstream concept. But when you read the best practices and what they tell you, they just tell you, well, don't put the stuff you don't need in the container. Sounds easy, but in reality, it's not. It's like it's as if you intentionally put stuff you don't need in the container image. That's not why it happens. You put stuff in because you think you need it, and because it's there, and you assume that it has to be there. And trying to get to that reduced image by hand manually is a complicated process. So trying to reduce the attack surface is a very manual process otherwise, because you need to understand the internals of the containers, and you need to understand the internals of the applications. And again, if you're an application developer, maybe you don't know how the application works under the hood. For example, not every app developer, web developer especially, is an assembly expert, but you end up with assembly and machine code behind the scenes, so you can't expect that. So that's one of the things you're recommended to do. You want to have smaller images, put in only what you need there, so you reduce the attack surface, so you can be exploited. Your application can be exploited with stuff that's just there, and it happened quite a bit. And the concept of least privilege is also in that kind of is related, because you're supposed to run with reduced privileges and limiting access. And again, it sounds good on paper, and it's one of the fundamental security concepts, but implementing that has always been challenging, because you don't necessarily know what kind of permissions you need. Even if you know the infrastructure, trying to do that with AWS and IAM is super complicated. I still struggle with it, and that's my favorite example to show when you have to do things manually, it's complicated, even when you're an expert. And if you go out there and read the blogs and about the container best practices, they are full of good advice, but again, they expect you to do a lot of manual work, or they also expect you to go with smaller base images like Alpine. Again, sounds good on paper, but in reality, there are a lot of gotchas you'll need to navigate. One of them is the packaging ecosystem. It's like going from Apple and iPhone to Windows Phone. it's like, you have so many apps with Apple, and then with the Windows Store, not so much, and it becomes a problem for a lot of applications. So it's it's one of the problems, and again, it's you want to make sure you have a containerized application that's ready to run in production, and it requires different stakeholders to come together, and that's something that adds complexity. And but DockerSlim and the application-centric approach, you eliminate those kind of manual steps. You help both application developers and infrastructure experts to deliver the apps faster. And with the reduced images, it's not just about security, it's also faster startup time. So now there are a lot of container-based serverless solutions. Even AWS has container-based Lambdas. When you have container images there, that if big, it takes much longer to start them. And you actually get charged every time the image gets loaded. So if you have bigger images and it takes longer to load them, you get charged a lot more. So it's not just about security, it's also about performance and other things that you would care about.
Yes, absolutely, absolutely. I think that the last point you raised is a wonderful. That's the fastest slim images has the fastest response time as startup time as compared to the bigger images. And on the topic of slim images and these Docker Slim that you created the tool out on. So people, let's say people are having some containers in their production. Tell us your views and your time spending with this tool. How can they use your tool to convert their images to the slimmer sizes? And because also the people thinking about the slim image, how much we can slim the images. Like, as we know, we have an operating system layer, then on top of it we have dependencies on top of it, then we run the code on top of it, then we have some privileges inside the Linux container. So what to remove from these layers? Either we'll remove this operating system, either we'll remove the let's say the npm package who's consuming so much memory, RAM and CPU. So what are the production best practices? You tell my audience which production to use, which to remove the images, what to bring into the Docker, and how much do you slim the images? Because I think it's a point where you don't want to go after that when crossing that point. So tell my audience, if they are using the Docker images today, how they can use the Docker Slims, the tools you have created, and plus your thoughts on the slimmer images.
Yeah, so in terms of what to remove and what to keep, there are opportunities on all sides, on the operating system side and the application side. One of my recent examples that I had to deal with is a web application. It's actually our user portal application. The server-side component includes the AWS SDK node package. It's huge. It's huge, and we need only small pieces of that package, but we're still stuck with that full package. It's like 50 megs, literally. It's one of the biggest NPM packages I've ever seen. So there, DockerSlim just trims not only the operating system parts that you don't need, but also the application package components that you don't need. And in some cases, it's literally test data that you don't want to have, but the publisher decided, well, wouldn't it be nice to also include test data with the package? Maybe for development purposes and debugging, it's fine. But when you're deploying to production, not so much. You don't want that, especially if you're deploying as the Lambda. So yeah, you can eliminate pretty much across all of those dimensions. And the best way to talk about the process is to take a look at what it looks like. So let's try Nginx as probably the easiest example to get started. So let me share my screen. All right, window. Okay. With DockerSlim, you'll and I'm using the CLI, but the standard CLI, but there's a nice interactive mode that you can use to pick different commands. So I can choose the build command this way, and then I can choose the target that I want, for example, Nginx latest, and that's pretty much it. If I run it, it starts. It goes through a set of steps. One of the steps is static analysis for the container image. The other steps include dynamic analysis when it creates a temporary instance of the container, and then it interacts with that container. So the message that we saw there, waiting for the HTTP probe to finish. So what happens when it starts the temporary container image, it runs HTTP probes against that image. And it's not just HTTP, it's other protocols as well. It's just that was the original name, and it generates traffic. And one of the things that it does, it goes through all open ports and it tries to discover services that are running there, and then it starts interacting with them, including crawling those services. So it sends a request and it gets a response back. It sees that, oh, it's a web application. I see a whole bunch of links. I'm going to follow those links. And it also does something similar with API specs. So if you have a web API with Swagger, you can point it to a Swagger endpoint, or you can point to a local Swagger spec, and it will go through the APIs and it will poke the APIs to interact with the service, and it does something similar with WebSockets, etc. And then once it's done, there's in the temporary container image, it has the original application, and it also has a built-in sensor that collects telemetry and the information it needs using different monitors. And then it grabs this information and it ships it back, and then based on that information, it builds a new image. And if we look at the image, Docker images, Nginx.
Wow.
So we went from 133 megs to 11 megs. And then if we run it again, run it rm Nginx Slim for 80. So now it's running. I'll make it a little bit bigger. And then if I open another window, is it showing up? I have an, oh, okay, it's showing up. Okay, and if I curl local host, I get a response back. And if I do Docker PS, I get a couple of things there, and including this Nginx Slim image. So we see that the Slim image is running, and we just interacted with that image. And it's not all, though. There's other stuff that DockerSlim does. For example, it generates a seccomp profile. And seccomp is one of the tools available with containers that helps you lock down your containers when they're running, where you have a list of syscalls that you allow or disallow, and with parameters and all in some cases, and again, leveraging the application information DockerSlim collects, it generates a seccomp profile that you can use. You can use the seccomp profile without the minified image. So if you just want to lock down your production environment and protect that application, then you just use the seccomp profile, or you can use both.
Yes, absolutely. So one thing can you elaborate on from the when you slim the images, we are using some kind of a probes. What are these probes are doing, and during this slim version of Docker, why these probes are mandatory? If somebody are listening or watching this session, if the question came into their minds, can you elaborate on this point?
Sure, and in some cases, you don't necessarily need them, but a lot, depending on the programming language, you have an application that dynamically loads different components with lazy loading. So in order to exercise the application, you need to generate traffic for the application. So those additional components get loaded, and that's what the probes are doing. They're trying to generate interactions to make sure that the major application paths are covered. And if you have a Ruby-based application, the main components get loaded. Otherwise, they won't be there, and that's kind of a part of the recipe. You want to understand the application and what it does, and for that you need to see it in action. Some of the future capabilities will also include being able to observe the application in production as well, but that's kind of a slightly different flow where they'll require a production environment, and before that you don't always have that production environment to get started with. But that's why you want to see what the application is doing. And for some of the compiled applications, you don't necessarily need that. But again, it depends on the application.
Yes, absolutely, absolutely. A lot of application do need some kind of a third-party environment or some kind of a seeding data before this come up. So I think that DockerSlim what does is try to understand what are the things that application needed to work properly, and then it try to understand those who application not needed in any way, and those party application don't need it. It's try to slim down, remove those bits from the images, and it's try to build a slimmer version of it. The demo that it shows is really surprising. It's take just one command and your whole image is converted from 131 megabyte to 11 megabytes. That's awesome. Thumbs up for the wonderful tool that you created. So also tell us, can we integrate this Docker Slim into the CI/CD environment? Let's say if my application is using some kind of 131 megabyte of images, do CI/CD system understand the Docker Slim CLI and then rebuild the images and these kind of stuff? So what's your points on this?
Yes, it is possible, and it's kind of interesting in terms of timing. Just the other day, somebody posted in discussions a drone CI integration example where they shared what they did in their configs, and yeah, pretty much all major CI platforms, they like pretty much all of them use Docker runners, and with drone, and that's based on, and that's pretty much container based CI by definition, and other CI platforms like Circle CI and GitLab CI, whenever they have containers, you can use DockerSlim. And without, if you have regular runners, that works too. There's a couple of examples in README docs how to set up DockerSlim. You can run a containerized version of it, so you can And in some cases, it's a little easier, but it does require a couple of extra parameters. So yes, there's a number of users that use DockerSlim in GitLab CI and Circle CI, and it's been one of those early requested features that people mentioned many times. And yeah, and we're also using that internally, but we're also trying to use the SaaS part to take advantage some of the integrations that you have.
Yes, absolutely. And can you just show some kind of a demos on Slim.AI, so how it can do some kind of
Sure.
stuff so people can understand the in artificial intelligence behind the Slim AI, how it's understand the images and how it's reducing the sizes.
Okay, so just to kind of to add a little bit of context, AI in Slim AI doesn't stand for artificial intelligence. Actually, we'll have some machine learning capabilities, and a lot of companies do that. But AI actually stands for application intelligence, and that represents this fundamental difference in terms of the approach, because a lot of the infrastructure-related tools, they are infrastructure-centric, and that makes them generic. But that's the reason why you have a lot of manual work, for example. But Terraform, not the same kind of tool, but it's a great example of an infrastructure-centric tool where it's really your responsibility to understand the application and to compose the application with Terraform before you take advantage of the automation it offers. And that's actually a lot of manual work, and that's we wanted to set us apart and show that our approach is different fundamentally, and that's why AI is there. Definitely, let me see if I can log in.
But Neema, thank you very much for correcting me, because I'm always thinking about the Slim AI for artificial. But I think that really the point you delivered was application intelligence is really one thing that you need to understand how your application built, what services are running on top of their applications, and how your application behave with different loads. I think you need to build a solution like that. So
okay, let me log in and. Right, almost. Okay, great. All right, so let me share my screen again. Window, right there. I'll make the window a little bigger. So here you end up landing on the homepage, and you can search for containers, and that's one of the examples of how Slim AI is different from DockerSlim. Obviously, DockerSlim is a CLI tool, and Slim AI is a SaaS. But one of the things you get with Slim AI is an ability to connect to a whole bunch of different registries, and then you can also search across all of them. So it's kind of like Google for containers. I search for a container image, and I'll use it again, Nginx, because it's a great example, and it'll find me container images across all connected registries. The public registries like Docker Hub, Quay, ECR public, Microsoft Container Registry, and then the registries I connected. So here I looked for Nginx, and I found Nginx in my ECR registry, and it also found the official image as well. So if I click on that, and one thing that's going to be a little different that I want to show that's not there, that you wouldn't get with the CLI, is this ability to understand the container image and understand the differences. So let's say it's something you deployed to production, and all of a sudden your application isn't working. So you didn't make any changes to the Docker file, but somehow something is broken, and that's a great way to investigate. So one of them, let's say I want to see what's inside the Nginx latest container image. Here, one of the things I get is this file explorer. So I get to interactively see what's inside of that container image, including content. For example, I can click on the entry point, and it was highlighted, and I can see not only the metadata but what's in that file. So it's super useful when you're investigating. And let's see, and then you can and then I can slice and dice the data and in that container image to get to the data I want. And it's interesting, but what's even more interesting is an ability to compare that to another version. So let's say I want to compare the latest version to another version, and version 121. And here, looking at the diff. So in this example, it's not the best example because it doesn't show things that have been added or removed. So stuff that's removed is red, stuff that's added is green, and stuff that changed is blue. And here specifically, let's see, index.html changed. Let's see how it changed. And here we get this interactive diff that shows us that's how it changed. And it's a super useful tool when you're trying to go through this break fix cycle. You deployed your container images and you're trying to make sense how things change. And one example of that is with dependencies. For example, you have a whole bunch of packages for your Node application, and the minor version change for one of the packages, and you ended up with a breaking change. And here you would be able to take a look. So it's not a Node application, but there I would go to the package.json file and then the package.log file, and then I would inspect how the packages changed and what was installed, and then I would take it from there. And that's a great way to debug problems. And it's also a great way to qualify the images. For example, there's a third-party image or an image that somebody in your team or another team has, and you want to understand, should I use it or can I use it? And yeah, you can kind of look inside, compare, explore, and then make that decision before you choose something. One of the good examples, like I said, is when you deploy a new version and the installed packages, they change behind the scene without you knowing. And when it comes to packages, it's a hot topic these days with the supply chain security getting a lot of visibility and buzz. But from the developer perspective, the supply chain is about reliability and predictability, where you care as a developer. You might care about security, but first and foremost, you care about your application running. And when it breaks, you want to understand what you have. And when it comes to the supply chain security and the standardized tooling around it, you like as bombs and all of that, you have a way to represent that information in a standard way where you understand what you have and how things change. So you have an information about a package. It was version ABC, and now it's version ABD, and then with the standard tooling and formats, like SPDX, for example, or Cyclone DX with S-bombs. You have a lot more opportunities to automate that discovery and understanding of those changes, as opposed to having to deal with these kind of one-off snowflake solutions. And that's what's great about it, because the more tooling and you have, and the more standard tooling you have, a lot, the more value you're going to get out of that.
Yes, absolutely. So DockerSlim is a CLI tool, and DockerSlim AI is a SaaS-based platform where you search the
Right.
images from the container that's are living in any public registry, whether on Docker Hub, ECR, or
Yeah.
ACR, and then you drill down to understand how Nginx 1.20.1 is different from the Nginx latest version, and you not only
Yeah.
dig down on the just the deepest layer, you can actually
Yeah.
track down which layer is changes and how it's changing, what's stored in it before that, and what's code is removed in that. So all these capabilities are all available. Also, we have connectors available to connect with the different registries. If you want to register to add your private registries as well on the Slim AI. So uh,
Yeah, and I showed just a slice of what's possible. There's an API where you can integrate, and there are other capabilities. I didn't show minification. Well, first of all, we're still rolling out the capabilities and exposing it, but it's there. It's just too much to show, and yeah, I wanted to show the things that you wouldn't get with the CLI, and yeah, there's a lot more that you can build on top of that, and integrate
yes,
with other systems and other registries. And yeah, and when it comes to the CLI and like DockerSlim in general, and it also applies to Slim AI and the SaaS, is that with minification, one of the, not necessarily gotchas, but one of the things you end up with a highly optimized image that doesn't have all metadata you would need for the supply chain tooling and the SBOM tools to generate the manifests that they need to generate. And that's kind of one of the gaps that will address, where when DockerSlim minifies and Slim AI minifies, it also generates a new set of SBOM metadata. So that way, because it knows the original metadata, and it knows what that original metadata maps into in the optimized image. So DockerSlim is in that unique position where it can optimize the image, and then it can close the gap in terms of metadata. So the other tools in the supply chain tooling ecosystem can function as expected. So that's one of the gaps that will close, and yeah, so
yes.
they'll make it easier to integrate with other tools.
Yes, absolutely. I think the show, what your the demos you show with the Slim AI, I think that's really we are missing at this moment of time, because we don't see what's changing at the hood. We are playing with the containers like we don't see what happening under the hood. Like we have some barrier because we don't dig into these files, how the code changes in these files. And now we have one, just go to the portal on the Slim AI portal, and you can search for any images, and then you dig down deeper, and all the things that you talk about the supply chain security. That's really a wonderful news for everyone who listening to us, because these are the biggest concern for the every company. Most, I think 98% of the companies was biggest concern was they don't see the containers, what the code changes. Because as you mentioned during the conversation, somebody changes the NPM packages and you don't know what the hell is changing in there. how it's different from the other version. And it's not easy as it should be, as you saying that. It's really difficult because the CLI toolings shows you the comparison version of what's happening, but you have to build out some commands to dig down these. But there is the no command. You just go to the dashboard, click on the things, and you can drill down. That's wonderful. I haven't explored it. This is my day one of learning DockerSlim AI, and I'm really impressed by the feature they have. What are the features?
And it's not only packages, it's also other things. For example, certificates. You have a new version of your application image, and you end up with different certificates, either unintentionally or intentionally. Understanding those differences, how things changed, is important. So you have a lot of different stakeholders who care about different things that you get out of the supply chain tooling. Security people care more about security. Application developers care about reliability and predictability. And obviously, there are a lot of different uses for that information.
Yes, absolutely. And one thing, can you understand? Because we already discussed about the SecCom profiles during the discussion. You have elaborated wonderful points on this. So, can we expect, or do we have right now, or can we expect this feature in the later down the road that this we have slimmed the images from, let's say, the 1.20.1, and the slim the images is got 13.6 megabyte. But when I see how the application now behaves with the new slimmer images, can I see the logs or some kind of a metrics, telemetry data to understand that my application and the performance is not going bad after slimming the images, or when I slim the images? Do we have some kind of capabilities available in here, or do these are planned for the futures?
So that's actually one of the not necessarily gaps, but one of the additional capabilities we want to offer with the SaaS, because those are natural questions. So one of the there are two questions that usually come up when you minify images. Number one, tell me what you did. And what I showed you with the SaaS is meant to address that question, where you can compare the fat image and the slim image, and then you can see how they're different and what changed. And so we want to address that question. And two, the second question is, does it still work? And for that, the intent is to provide an easy way to integrate with your tests, whatever they might be. If you have end-to-end tests, the idea there is to plug them in either by providing them during the minification flow, or by connecting them externally, kind of bring your own tests and all of that. So, and that way you'll get to validate that, okay, I got an optimized image. This is how it changed. This is the stuff that was removed and stuff that's still there, and then it still works because the tests that I have, they run, and I get an image that meets the requirements. And that's one of the reasons why we wanted to build the SaaS, because there are all those additional things you want to be able to do for this kind of end-to-end flow, and you need to have for production. And you either build it yourself, or build all of those steps yourself, or you leverage an existing setup, which we would offer.
Yes, absolutely. So wonderful elaboration to my question. And another one question before I let you go. Let's say in the Slim AI in the future, can we see some kind of the best practices that this container can have these much of privileges? It's required. And if you, as we know, the least privileges model, we should try to follow. But the engineers like who are really the new into the container, yet don't understand the least privilege model. Can we see in the SaaS platform is hint us that these are the privileges that you wanna consider when building the images?
Yeah. So it's a part of this third component. Understanding the image with X-ray is one part of it. You discover the information about the image, and then dynamic profiling kind of adds more to that. information that you understand, and like the insights about what's inside and all of that. Then you have minification further down. The other piece that we're working on is this kind of structural validation and verification, where we take the information and the insights, and then we apply a rule engine that will tell you this is how close you are to the container best practices. Your image composition, you're using root users in your container images, and you shouldn't. And so we'll be able to kind of provide the gap analysis, a gap report. This is where you are, this is where you want to be, and eventually we'll also provide automated capabilities to address those gaps. So we would help you rewrite your Docker files, and that's one of the fundamental approaches. But DockerSlim and SlimAI, we work with the tools you have, and that's why we're not introducing a new interface. We're not introducing new tools, and we're not asking you to change, because every time you ask people to change, it's a hard sell. It's difficult to do, and then asking people to throw away the tools and the processes they have is challenging and not realistic. That's why we come back to the Docker file. We'll improve your Docker file, but build packs, for example, they provide a wonderful solution, but they take away your Docker file. And in some cases, it might be fine, but in other cases, not so much. There's a window where it's sufficient, but then you outgrow it, and then you need to customize things. And then you're kind of forced to do it the build pack way, and there are a lot of things. So we want to allow you to keep the Docker files you have. We'll help you improve them. We want you to keep your base images and the application images you have, because you have the package ecosystem you rely on, and other things, the processes that you rely on. We're not asking you to switch to Alpine. No, you use Ubuntu or Debian as your base image. That's okay. We want you to have developer-friendly containers when you're developing, but then we want to automate the difficult process of going from the developer-friendly containers and the stuff that's easy to use by developers to the production-ready version that makes the DevOps people and SRE people happy.
Yes, absolutely, absolutely. That's a wonderful demo, it's a wonderful explanation to all of my questions. So I learned a lot on day one of learning the DockerSlim images. So wrap up, if I ask you to wrap up in a whole that conversation in just 2 or 3 words.
Okay. Yeah, try DockerSlim. See if it works. If it doesn't, say something about it.
Yes, absolutely. Catch up on the Twitter handle on CalQuest. It's been mentioning on the LinkedIn chat or to YouTube chat, and you can grab the link and join him and talk us about what the feature you want to see in the future, and all the things I think that you showed tonight. I think we are missing for a very long time, and it's been a wonderful explanation to those concepts as well. So it's a great tool. I think everybody can to try to test out. And if you want to try to test out and need show your feedback, let us know on the Twitter side. We will catch you up. We are here for your feedback, and feedback is important for any project, whether it's open source or any kind of project. So wonderful, Kyle Quest. Your time is really important for us, for being and helping us understand DockerSlim. What you just showed is a wonderful, and the future. I hope you do the wonderful things with this tool in the future as well. Thank you very much. Enjoy.
And thank you for the opportunity to chat about DockerSlim and other things.
Thank you.
Thanks a lot.
Hope to catch you again in the future as well.
Absolutely.
Thank you everyone who joined us today. Stay safe, stay healthy. We'll see you again in the next episode. Bye bye. Jump into the container day. Tell us about your journey into the AWS as a principal software engineer. You were recently hired there, I think, year and a half ago. And how you enjoy the time, how you find the team more exciting, and what is you currently doing in AWS at this moment of time?
Yeah. So, yeah, as you mentioned, this is fairly new to me. I actually just joined in January, so it hasn't quite been a year yet. But I was excited with AWS's use of Containerd, specifically in Fargate, and now coming to EKS. And AWS as a whole is obviously very focused around containers and container offerings in the cloud. And the container organization that I'm a part of develops all those services, the container registry, the Kubernetes offerings, the serverless container offerings. So it's a great place to be where, Containerd is a key part of what they're doing here. And so the VP of the containers area was looking for more Containerd talent and open source talent, and it just seemed like a good time for me to try something new, to try a new company, a new cloud. And I've been very happy with the ability to continue my open source work and also help determine how that integrates into product offerings in the cloud. So yeah, I've truly enjoyed it so far, and it's a great organization.